Hey, welcome back to CSCI335. It's the Friday lecture. Today we're going to be going over more HUD stuff. So sort of some housekeeping items. Today is more HUD, specifically in C++. Monday we're going to do HID because I was thinking we'd get to it today, but we probably will not. This is stuff like the player controllers, remotes, Wiimotes, I should say. That reading is in the book, so you should definitely be checking that out. Let me get you the page number really quick here. I just need to log back into my Moodle. It's a different page number in the different editions, so. Um, 9.1 to 9.3. So definitely be reading that. Next week, Wednesday and Friday, we're going over player stuff, player movement specifically. For that, I want you to read 16.1, 16.2, 16.6 through 16.8. Or actually through 16.9, excuse me, as well as 8.1 and 8.2. So we have a pretty busy week next week. Also, your project is due coming up next week here. Project 1, that's due on Wednesday, March 3rd. Oops. Stop you writing that project. Due on Wednesday, March 3rd. So hopefully you're making some good progress on that. I've helped some people online and things seem to be going fairly well. So I'm going to go ahead and power up. Well, actually, what I'm going to do first, so the topic of the day is HUD and C++. First, I want to sort of motivate why you would do this. So almost everything in blueprints can also be done in C++. Pretty much everything can be. Including the HUD. So why would we do this? I just wanted to take a quick pause to discuss the reasons why we might work in C++ instead. One, comfortability. Some engineers only know C++ and they don't have a desire to learn blueprints. Two would be compatibility. So sometimes you can pull code from other games easily into C++. Third reason would be working together on a common problem. So sharing the workload. For example, C++ can be merged and resolved. Blueprints cannot be. let me give you an example of that. So let's say, let me bring up program that'll help me demonstrate this. So I'm going to bring up my own game project, Noise Paradox, and show you how we worked this with being able to resolve different versions of the file. So this tool, and some of this coverage is in the book. Chapter 2, I think, talks about perforce. It's not so important that you understand what perforce is. Perforce is a source configuration and code sharing tool. But for example, in the source category here in NP, this is the project that I'm working on, you can see that there are going to be a couple files which have changes. So this one, for example, has 4 changes, 2 out of 4. I'm currently on my second change out of the 4. And I wanted to just show you and highlight this area here. So these were the 4 different file versions of this file that were checked in. The other programmer on the project mainly is Vic, and then there's me. Now, if I click on both of these and I right-click, I can do a diff selected. Oh, those are identical, but let me try diff selected here. You can see the changes that took place. So in this case, there were 2 changes in this C++ file. This is in NP character, which is our character file. So this shouldn't look too different from like the third-person character you used and all that stuff. In this case, Vic added matrix type equals matrix type A, and he also added actually I made this code change. I added a matrix vulnerability system, which basically says how much damage to increment by if a character is getting injured by a different character type to make it sort of dynamic. Now, this change was implemented inside of the take damage function, and it's fully visible here. The thing is, you cannot do this. You can't just take a line of, what we would have to do in blueprints to pull this off. You can imagine what we would have to do. We would have to say something like, so sort of in a quick aside. So to summarize what I'm talking about here, for number 3, to understand why, we have to understand source control. So I can make a change to a file. Simultaneously, someone else can. And what are the results? Well, the results should be, if I added something to it, the new version. So if you've got sort of Ben's version, Vic's version, Ben goes and adds something. Vic goes and adds something. The final version should be Ben's plus Vic's, and this is kind of the final version. It merges down into this area here, and that becomes the final version. So, and that is possible because if you take a look at the code, all I'm doing is adding something here. Now, maybe Vic came along and added another function. In fact, that was done recently on this project where we added multiple functions, and then it would just add them both, and then this NP character CPP4 becomes the final version. Now, to do that in PowerPoint, or to do that in blueprints, we can't. Because let's say we had some blueprint that says take damage. Take damage needs to do, and as I just described the system to you, basically what it means is, in my game, I've got some, it's kind of like a tower defense game. There's some friendlies that you can boost their stats of, you can get buffs for them, and like they each have a different type, and then they're attacking enemies basically that each have a different type, and some types are more resistant to damage than others. For example, air-based minions such as a Raven does very well against ground-based robots. So it's like a paper, rock, scissors sort of matrix of vulnerabilities. So we want to apply the vulnerability matrix, and then we want to do final damage. So in blueprints, we'd have to do this. We'd have to do something like, whereas in C++, we do kind of what I had shown you already. I can take a kind of screenshot of that. C++, we just modify the take damage function. Now, maybe that should be its own function, you could argue, but that's fine. That's just the route I chose to go. Always does that. Always. I don't know what the deal is, why it decides to tilt it is beyond me. So this can be merged. The above cannot be, because ultimately underneath, if you think about the file, and this gets into some sort of operating systems topics, but if you get into the file of the take damage, apply vulnerability, final damage, if Vic went in and made a change to that same blueprint, it would be very hard to merge it automatically. You could do it by sight. You could go in there and make the changes, but you cannot do it in C++, or you cannot do it in blueprints automatically. So merging just pulled up some weird thing. Merging happens in C++, can't happen. And they are working on a tool for it to work in blueprints, but it's very difficult because if you take a look at an actual blueprint file, the blueprint file is blueprints are binary files. C++ is a text file. That's where the key difference remains. And the reason I'm covering it today, I mean, we're kind of going through C++ stuff, and it's important to understand why you would do this. So that number 3 is just a huge reason you would do it. If we take a look at the UAsset, any old UAsset file, let's take a look at a player-based one, like first person, sort by name. I use this everything tool to search on stuff. It is so nice. It's made by Void Tools, and it's so much better than the search tool for Windows. Anyway, first person character UAsset. So this is the first person character blueprint. They always end in UAsset files. If I open this up in a program such as Sublime, you're going to see not very useful information. And it'll take a second to load up because it's kind of big, but Come on, Sublime, load it up. I don't know what's going on here. It's not. Maybe I can load it up in Notepad or something. Yeah, it's taking forever. Try to do something else. Sublime is nice. It's kind of old at this point, but it takes you're all open in code, VS Code. Yeah, Sublime sometimes takes just forever to do stuff. So I'm kind of switching pretty much fully to VS Code at this point, but. And we're going to say we want to open it anyway. It's a binary file, which is probably why Sublime had trouble with it. So notice it's all just a bunch of, binary. I mean, there are some useful tidbits in here, and it does some things, but it's basically a binary file. So this is all just text code, and you can't make any sense of it. Like, how would we merge this? Well, there's actually at Epic, if you can find a way to merge. Like, if you can find a way that if someone makes one set of changes in a blueprint and someone else makes another set, and it automatically sort of takes those and keeps the stuff that you want and gets rid of the stuff you don't want, you're sitting on a gold mine, basically. Epic would probably pay you hundreds of thousands of dollars for that technology. I'm quite serious. It's very difficult to do. There are people working on it, and I don't know how far they've gotten. This is what it actually looks like in full text. So as you can see, it's just, this kind of harkens back to CSCI335, where this is literally just a bunch of machine code, and so we can't merge that. So hopefully that helps motivate why we would want to do this in C++, because if you've got a big team, let's say you've got 300 people or something on a team, which is not uncommon for game teams these days, you want to be able to have people working on the same thing at the same time. So, hence, we come to C++. So here's how we're going to do this. So we're going to kind of transition here to, let's make a HUD with help from C++. And it's not fully C++ because we are going to use parts of blueprints, and that's normal. But we're going to do as much in C++ as we can. So the idea is going to be we're going to have a player meter for, I don't know, we'll use it for score. So that's going to be sort of our design. We hit an object. And the meter goes up. So very basic design. It's going to seem slow and cumbersome at first to do this in C++, but once you get used to it, it's not too bad. Just like anything in computer science, really. So first, the steps we're going to take. First, we load editor from Visual Studio, create a new C++ class, derived from a widget. We make our variables, except this time we make our variables in C++. We make the bar in design view and bind to those variables. I think that'll be a good way to do it. So let's go ahead and get started. Modify C++. So I'm going to take a quick pause. This might be in two-part videos, and this would be the first part ending here. And we'll start the second part up from me loading up Visual Studio.